can break down into what? 4 and 6. So we square root 4 and 6, take the 4 out, and you get it too. 98 can break down into?
49 and 2.
49 and 2. The 49 comes out and it's a? 7. Okay. And then, that is not a plus sign. Then 125 can break down into?
25 and 5.
25 and 5. The 25 comes out and it is a 5. Okay. So we have 2 root 6 plus 21 root 2 minus 20 root 5. And I put them all together because obviously I can do that. Can I do that? No, that's stupid. It was you, I'm sorry. It was just foolish. That's what it is. It's foolish. When can we put together radicals? When they have the same radicand. The number under the radical. It's like putting together an x and a y term, correct? None of these are the same, are they? Nah. So what do? We box it and move on. Yes.
It's like your feelings. Yeah.
Box them and move on. Yeah, Chloe.
No, you just compress
this, but
Okay.
box.
I'm still up in the air on that one.
Can I box tape
You
a
get
little
to
longer?
choose.
I get to choose what's best for you.
You choose like how much is worth.
70%
Which way?
is what I'm thinking about right now. Might go 75. I don't know. Options are endless. Okay, I just
do
choose
100
what's best
that
for you.
I want to lose with
Teacher
Tom's
gets to choose for their like class.
Yeah.
I say do 100.
You guys
100%. Okay, I'll take it under
This
consideration.
doesn't matter.
I'll take this under consideration. I'll let you know the day before the fun. Okay, good. Okay. All right. Let's go. Nope. Okay. Guys, let's go. So, we're going to multiply by distributing. When we hit a bracket, we stop. So even if I put a term at the back, would I distribute it in? No. So I'm going to get, when I multiply coefficient times coefficient, radicand times radicand. 2 times 4 is 8. 3 times 6 is 18. Then I go to the next one. 2 times negative 3 is negative 6. Root 3 times root 5 is 15. Am I done? No, because root 18 can break down into 9 and 2. The 9 comes out and it is a 3. And then this one, none. So my answer is going to be 24 root 2 minus 6 root 15. I can put them together, obviously, because they're like terms. No. What do? Box it. Move on. Okay. C has a monomial in the denominator stuff. It has a monomial in the denominator, 2 root 5. When there is a monomial denominator, what must I do?
Times it by radicand.
Times it by whatever the radicand is. So root 5. If there's 2 terms, you multiply by the conjugate, which is where you were going. Conjugate. All right. So we're going to multiply by root 5. I don't have to multiply by 2 root 5 because I just need to rationalize the denominator. So I need the denominator's radical to go away. And when I have just a root 5, the easiest way to get it to go away is just multiply by root 5, because root 5 times root 5 is 5. So I only have to multiply by what's under the radicand if I have a monomial denominator. So then I have to distribute my numerator because it's a binomial. So I go 3 times root 5, so I get an equal sign running down the left side, is 3 root 5. And then plus 2, root 2 times root 5 is root 10. Over 2. Root 5 times root 5 is 5. So I'm going to get 3 root 5 plus root 10 over 10. And what do I have to ask myself then? Can I take something out of every term? So this is a 3. What's in front of this term? A 1 and a 10. Is there anything I can take out of 3, 1, and 10?
A 1.
A 1. And if it's just a 1, then I take out nothing because it doesn't have to. D, I have a binomial denominator. And when I have a binomial denominator, I have to multiply by the conjugate. So if I have 4 root 2 times 6 root 3, I'm going to multiply by 4 root 2 minus 6 root 3. 4 root 2 minus 6 root 3. So I'm going to have to FOIL. Equal sign. So I get 2 root 3 times 6 root 2. 2 times 4. What? 6 root 2? That's a 4. 2 root 3 times 4 root 2. 2 times 4 is 8. Root 3 times root 2 is root 6. And then 2 root 3 times negative 6 root 3. 2 times negative 6 is negative 12. Root 3 times root 3 is 3 in brackets. Negative 3 root 2 times 4 root 2. Negative 3 times negative 4 is negative 12. Root 2 times root 2 is 2 in brackets. Negative 3 root 2 times negative 6 root 3 is positive 18 root 6. All over 4 root 2 times 4 root 2 is 16 times 2 in brackets. Now if I'm multiplying by the conjugate and I'm doing it correctly, my middle term should do what? Cancel. 4 root 2 times negative 6 root 3 is negative 24 root 6. I better get a positive 24 root 6 or I messed up. 6 root 3 times 4 root 2 is positive 24 root 6. And then I should be able to immediately do this. If I can't do that, you messed up. You either messed up in your multiplication or you messed up and didn't multiply by your conjugate. Then I have 6 root 3 times negative 6 root 3. 6 times negative 6 is negative 36. Root 3 times root 3 is 3. And so I get 8 root 6 minus 36 minus 24 plus 18 root 6 all over 16 times 2 is 32. 36 times 3 is negative 108. And so then I get 8 root 6, 18 root 6 is 26 root 6 minus 36 minus 24 more is negative 60. And then what's negative 108 plus 32? Negative 76. And then I can take a 2 out of each, right? 2 out of 26, 13. 2 out of negative 60, negative 30. 2 out of negative 76, negative 38. So I get 13 root 6 minus 30 over negative 38. Wow. Okay? Everyone did okay on that one? All right. What we're going to do is we're going to turn to our notes. We're going to turn to solving. Yep, number 2.
Oh, this one?
In radicals. Yes. So we're going to be on page 7 shows it, but we're not going to go there. We're going to go right to page 8. Examples to solve using the steps above. Well, I'll do the steps between each page, but we're just going to go through them. So we have, for our examples on page 8, we have square root of y minus 1 plus 7 equals 13. Now this is where I'm going to get into restrictions. I didn't talk about restrictions to this point, even though I know we had variables under radicals, but I didn't want you to get overwhelmed with them. I just wanted you to learn how to add, subtract, multiply, divide, and not really think about the restrictions. The key thing about radicals, or square root functions, cube roots is different, but it's only with even index roots, so square roots, fourth roots, sixth roots, eighth roots. You can't have negatives under your square root. Can you take the square root of 0? Yeah, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of any positive number I can do, and I can do the square root of any zeros, correct? What I can't do is I can't take the square root of the negative. We agree? So for example, if I found y equal to negative 2, I go negative 2 minus 1, I get negative 3. Can I take the square root of negative 3? No, so negative 2 is out. What if I chose negative 5? Negative 5 minus 1 is negative 6. Square root of negative 6, is that okay? No. So I have to, whenever I have a variable under a square root function, I have to state what my y's can be that would actually work. So what do? I say what's under that square root. So what's under that square root? So this is going to be my restrictions. What's under that square root has to be what? Has to be positive or 0, right? So what's underneath it? Y minus 1 is currently underneath it, correct? Well, y minus 1, when I fill in y, whatever I filled for y minus 1 has to be greater than or equal to 0. We agree? So what's underneath that square root function has to be greater than or equal to 0. Yes? So whatever I put under that square root has to be greater than or equal to 0. It has to be positive or 0. Yeah? Now all we have to do is actually isolate y. Inequality signs. What you were taught in the past is if you do anything to an inequality sign, it stays the same except if you divide by a negative. So if I divide by a negative, my inequality sign will flip. But it's only division. If I multiply by a negative, nothing happens. If I add a negative, subtract a negative, nothing happens. It's only if I divide by a negative. So what am I going to do here to get y by itself? Just going to add 1. Does adding change my inequality sign? No. Does subtracting? No. Does multiplying? No. Does dividing? Yes, only if you divide by negative. If you divide by positive, nothing happens. So my inequality sign is not going to switch. I'm going to say y has to be greater than or equal to 1. Now let's see if that's true. So the statement is y has to be greater than or equal to 1 or I can't take the square root of this. So if I plug in 1, 1 minus 1 is 0. That's good, right? What if I plug in, okay, so that's 1. I have to plug in greater than 1. So say I plug in 2. 2 minus 1 is 1. Can I take the square root of 1? Yep. So those are the restrictions. Y has to be greater than or equal to 1. If y is less than that, will it work? Let's try it out. Let's pick 0. 0 is less than that, right? So if I go 0 minus 1, what do I get? Negative 1. Can I take the square root of a negative number? No. So I know I'm right. I can check my restrictions. So my restrictions are y has to be greater than or equal to 1. So no matter what I solve and get in the end, I'm going to have it greater than or equal to 1. So what are the steps for solving? The steps for solving are reverse BEDMAS. We agree? That's always been the steps. Whenever you're solving for a variable, you reverse BEDMAS, correct? Now, people go, well, where the heck does root? Where does a root fall in BEDMAS? Brackets, exponents, division, multiplication, addition, subtraction. Where the heck does a root fit? Exponents. Remember, I told you this, you did this last year. Say you had square root x. Remember I talked about this? Square root x, x is just to the 1, correct? The index on this would be a 2 if there isn't one. So you were taught last year you can make these rational exponents by dropping this underneath. So this is x to the 1, and the 2 can drop underneath, 1/2. So it actually is an exponent. A square root is an exponent. You just didn't know it, or didn't think about it that way. So it falls under the E of BEDMAS, correct? So I'm going to do my addition, subtractions first, my multiplication, divisions next, my exponents next, my brackets last, right, when I'm solving. So what am I going to have to do here first? That square root function, get rid of it, or the 7? I'm doing reverse BEDMAS, so I have to move the 7, the addition of 7, right? So how do I move an addition of 7? Because the addition subtractions have to go first. So I'm going to subtract 7. And I'm going to get square root y minus 1 equals 6. And she sent me an email too. Okay, so we have square root y minus 1 equals 6. We agree? Now what's left? The square root. The e, the exponent, technically. How do I get rid of a square root? What's the opposite of square rooting something? Squaring it. So how do I get rid of a square root? I'm going to square both sides. So I'm going to square this, and I'm going to square this. Now how does that work? Well, if I had x to the 1/2 and I wanted to get rid of the 1/2, I could multiply it by 2 over 1, which is squaring it, correct? If I multiply it by 2 over 1, I get 2 over 2, and they would cancel, so I would just be left with x, wouldn't I? So that's why the opposite of square rooting is squaring it, because square rooting is to the 1/2. If I square it, it's to the 2 over 1. 1/2 times 2 over 1 is 1. It gets rid of it. So that's why the opposite of square rooting is squaring. So this squared cancels off this square root, and I'm left with y minus 1 equals 36. Now what do I have to do? Add 1. Y equals 37. Now I check. Is 37 greater than or equal to 1? Yeah, so it fits my restrictions. But I also have to check. Every single time I solve a radical, I have to check. Because sometimes it follows my restrictions and it works for my restrictions. But when I plug it back in, it doesn't actually work. when it doesn't actually work, it's called extraneous. It's a no solution. So we have to check. So when you solve a radical, your last step always is to verify or to check. And how do you check? You always plug back into the typed version. Nothing you've touched. So you go back into the question, into the typed question that I typed for you, and you rewrite that. So we're checking y equals 37 back into the typed question. So the typed question at the top of your page is y minus 1 plus 7 equals 13. And when you check, there's like an electric fence running down the equal sign. Nothing can cross over. It would hit it, it would bounce back. So when you're verifying or you're checking, everything on the left stays on the left, everything on the right stays on the right, and you just see if they equal each other. You don't move anything back and forth. There's an electric fence down the middle, it can't move. So whenever you're checking, whether you're in grade 10, 11, 12, 13, 14, I don't know why I kept going, university, when you check, you can't go over an equal sign. You just see if left side equals right side. So we're going to stick over here, and I'm going to plug in for y 37. So 37 minus 1 plus 7 equals 13. 37 minus 1 is root 36. Plus 7 equals 13. What is root 36? 6 plus 7 equals 13. And then people will say, done. 6 plus 7 equals 13. Unless my child can look at that and say, you're right, those are the exact same numbers, you are not done. My child is smart, she'd probably figure out 6 plus 7 equals 13 and be like, that's a true statement. But unless she could look at it and say, 13 equals 13, those are the same, Mom, you're not done. Could she say that currently? No. You have to keep going till you go 13 equals 13. Now do they look exactly the same? Yes, now you're done. You can't be like, they're the same. No. 13 equals 13. We need to match. Then I'm done. This is my solution. So I would go to my multiple choice and I would circle 37 as the multiple choice answer. The numeric response, I'd go from the left to right and I'd go 3, 7. If it was numeric response, just to remind you, you fill in boxes from left to right. So it would be 3, 7, done. You don't have to fill in all the boxes. But it's always left to right like you read from a book. Okay? So the next one is root 7x plus 1 equals 15. Square root 7x, then plus 1 equals 15. I want you to try it. Restrictions, solve, verify. How do we state restrictions? We take what's under the square root and we say it has to be greater than or equal to 0. So our restrictions, we label, we take what's underneath the square root, we say 7x has to be greater than or equal to 0. How do I get x by itself? Divide by 7. When I divide by 7, does my inequality sign flip? No, it only flips when I divide by negative numbers. Yes, that's the only time. So I divide by 7, and I get x has to be greater than or equal to 0. Then I can check my restriction. So I plug in 0. 7 times 0 is square root of 0. Good. Plug in 1. 7 times 1 is the square root of 7, which I can find. Right? So the restriction seems good. Now, how do I solve? I reverse BEDMAS. So I have to get rid of the plus 1. So I subtract 1. I get root 7x equals 14. And then I square it to get rid of the square root. 7x equals, I don't remember what this is, 196. Divide by 7. And x equals 228. 28. Then I have to check it. Because just because the answer works and just because it is actually greater than or equal to 0 doesn't mean when I verify it, it will actually work. So I do check every single time. So I rewrite out my original. Root 7x plus 1 equals 15. And then I plug in my x equals 28 and c. So I go root 7 times 28 plus 1 equals 15. 7 times 28 is 195? 6? Do you get 197? Oh, it's the square root. Lepp, grab a mitt. That's 14, right? Sometimes I scale myself. 15 equals 15. So this one's good, right? Okay, we're going to look at the next one. M equals root 2 minus m. So, the last few, when we went to solve them, they were linear. We didn't get any squares, right? Coming in with your wedding cake?
Do you like my cake?
So, so here we have m equals root 2 minus m. What's the first thing we have to do? Restrictions. Let's go try them. So we have restrictions. And we have 2 minus m has to be greater than or equal to 0 every single time, because what's underneath your square root has to be greater than or equal to 0. We agree? What's the first thing I'm going to move? The 2. I'm going to subtract it. So I'm going to get negative m is greater than or equal to negative 2. Then I'm going to divide by negative 1. Dividing by negative 1. What happens when I divide by a negative and I have an inequality sign? These cancel, but the inequality sign flips. So we're going to get m, instead of being greater than or equal to, it's going to be less than or equal to 2. And you should check, you should be able to, because you're going to verify, you're going to check your restrictions. If you forget to flip, you'll realize that it's giving you negatives. So it has to be less than or equal to 2. So I plug in 2, I get 2 minus 2 is 0. Yay. I plug in 1, 2 minus 1 is 1. That's so good. I plug in 0, 2 minus 0 is 2. Good. What if I forgot to flip it? It would say m has to be greater than or equal to 2. So I plug in a 3. 2 minus 3 is net. Oops. You should check your restrictions, and then you'll catch if you forget to flip it. Make sense?
Yeah.
All right. Now, this is a little harder because there's nothing to actually move. Okay? So your first step in solving radicals is to actually get the radical by itself. We were doing it before because we were using reverse BEDMAS anyways, correct? When you're stuck, when it's something like this, always just remember when you have a single radical, get the single radical on one side and everything else on the other. Okay? We did it in the previous 2 examples without you even realizing that's what you were doing. Getting the radical by itself. And the reason why you want to get the radical by itself is because we have to square. Correct? To get rid of the square root, we have to square. If you actually have the m with it, you're going to have to FOIL. Do you want to FOIL with a radical? Not unless you're forced. Right? So when you're solving a single radical, always get the radical on one side and everything else on the other. That should be your first step. So we're going to write that down as a little reminder. We didn't need it before, but we're going to keep it down. So single radical always get the radical on one side and everything one side of the equal sign. And everything else on the other side. So that's your first step always. We were already there. And now once I have the radical by itself, I can get rid of it by squaring it, right? This is going to be my problem though. I'm going to square this, and what am I going to get? M squared. I'm getting the quadratic unit that we just got out of. M squared, and then I'm going to square this, and the square and the square root cancel, and I'm left with 2 minus m. And what did I teach you in the quadratic unit when you have to solve? Whenever you have a squared, you have to move everything to one side and set it equal to 0 every single time. So if ever, from now until eternity, you have a squared variable, you have to get everything to one side, set it equal to 0 every single time. When you have a single, like m or y or x, you can get everything to one side and then get the y and the x by itself, right? That was the rule that we learned in grade 10. But then we hit grade 12, we talked about grade 12, we did not. We were in 11. Wow, we really just advanced very quickly there in my mind. Okay, we're still in 11. When we learned in 11 is that we have to move everything to one side, set equal to 0 whenever you have a squared. And we have a squared, correct? So I'm going to have to add the m and subtract the 2. So I'm going to subtract the 2 over, and I'm going to add the m over. So I actually get m squared plus m minus 2 equals 0. How do I solve this? We have two ways. Factoring or quadratic formula, correct? I always look for factoring first because it's the easier one. So I'm going to check for factoring first. So I'm going to go what times what equals the first times the last, so negative 2. What plus what equals 1. And I'm going to be honest with you. We use solving quadratics almost every single unit in grade 12. It's how we end everything. So if you can't do this, it's going to get real ugly next year because it's how we finish everything. We even solve quadratics with trig. So, what multiplies to give me negative 2 and adds to give me 1? 2 and negative 1. Do I have to do decomp? No, because there's a plus 1 in front. I can go right to brackets. So I can go m plus 2, m minus 1 equals 0. So that's the grade 10 part. What's the grade 11 part? Set each of them equal to 0 and solve for m. So I'm going to get m plus 2 equals 0, m minus 1 equals 0, subtract 2, m equals negative 2, add 1, m equals 1. Now what's my restriction? M has to be less than or equal to 2. Are both of those less than or equal to 2? Yeah, so they fit in the restriction, but we still have to verify to see if they actually work. Because just because they fit in the restriction doesn't mean they're actually an answer. So we have to check both of them. This is why I'm not doing it on the paper that you have in front of you, because it takes a lot of room. So we're going to check it. The original was m equals square root 2 minus m. So that's what I'm plugging it into. So I'm going to get negative 2 equals the square root of 2 minus a minus 2. Negative 2 equals the square root of 4. Negative 2 equals 2. Yep, it's true, so I'm going to move on. Is that a true statement? Is that true? Does negative 2 equal 2? No. So this one doesn't work, even though it fit. We're going to circle it. When they don't work, you circle it. You put a line through it, because it doesn't exist, and you say extraneous. Extraneous. And we're going to do this a lot in grade 12 as well. So you will always, whenever you get a solution, you will plug it back in and check it. If left side doesn't equal right side, you circle it, put a line through it, and say it's extraneous, which means it is a solution, but it doesn't work. Okay? Now we have to check the other one. So it's m equals root 2 minus m. 1 equals root 2 minus 1. 1 equals root 1. 1 equals 1. So this one works. Now the catch is sometimes both of them work. Sometimes one works and the other one doesn't work. Sometimes none of them work. So if both of them are extraneous, then there's no solution. There's no answer that works. Okay? Now if you don't remember to check, do you think one of my multiple choice answers will be m equals negative 2 and 1? Yep. What if you don't check? You're going to circle that one, aren't you? When in reality, my multiple choice answer that's correct is just m equals 1. Make sense? So the multiple choice answer has to be the only one that works. So I'll put m equals negative 2 comma 1 as one of the answers, and it's not true because m equals negative 2 doesn't work. So if you forget to check, you will pick the wrong answer. All right, you guys are going to try the last two. So there's n minus square root n equals 2. And the other one is going to be 3x squared plus 2 equals 2x plus 1. Don't try this one until we try this one first, actually. Just do this one. What am I going to have to move first? I can subtract the n. Now I have negative root n equals 2 minus n. Is the root by itself? No, there's a what sitting in front of it? a negative 1. So I'm actually going to get root n equals, now the negative 1 just goes to both terms. So I'm going to get negative 2 plus n. Before I move on, I should have stated restrictions. How do I do my restrictions? I take what's under the square root, which is just n, and I say it has to be greater than or equal to what? What does it always have to be greater than or equal to?
0.
0. A question on the test is probably just going to be what's the restrictions? You don't even have to solve it. What am I going to do now? Once I get my radical by itself, then what do I always do? Square both sides. So I'm going to square this side. The squared cancels off the square root. I square this side, and this is where people mess up. What the heck did I tell you to do when you get a squared? Do not just start doing math. What do? Write it out twice. If you don't write it out twice, you guys will tell me it's 4 plus n squared, which it is not. So whenever you have a squared, cross off the squared, and then just write it out twice in FOIL. So I'm going to get n equals, and then FOIL that. Try it out. You should have n equals, and then we FOIL. 4 minus 2n minus 2n plus n squared, which results in n equals 4 minus 4n plus n squared. Wait, I have an n squared. The moment I have an n squared, x squared, y squared, m squared, doesn't matter. The moment I have it squared, I must move everything to one side and set equal to 0 every time. I have no options, correct? So what am I going to have to move? The little n that's by itself. It needs to get on the other side so it's equal to 0. So I'm going to subtract n. 0 equals, and then I rearrange it, n squared minus 5n plus 4. Then once I have it equal to 0, I can try factoring it every single time. Every single time. So whenever one of your terms is a squared, make sure your phone's away. If one of your terms is a squared, you have to get it all to one side, set equal to 0. That's your phone. I tried to do it all sneak-like, but then you didn't. All right. So what times what equals 4? What plus what equals negative 5? Is there anything? No. So what are you going to have to use? Quadratic formula. So A is 1, B is 5, C is 4. So,
Negative 4, negative 1.
ah, poop. It does work. I just said poop. Oh, I just said it again. Would have caught our mistake when we go do quadratic formula and got 4 and 1 is the answer. Yep. Negative 4, negative 1, negative 4, negative 1. So we get n minus 4, n minus 1, n minus 4 equals 0, n minus 1 equals 0, n equals 4, n equals 1. Box them and move on. Is that what we do? Box them and move on. Are we allowed to do that? No, what must we always do? Check. Because just because they work, and just because they fit my restrictions, which they both do, my restrictions are n has to be greater than or equal to 0, which 1 and 4 is, I still have to check. And I check back in to the very original typed question, nothing that I've touched. The original typed question is n minus root n equals 2. So I'm going to go 4 minus root 4 equals 2. And then people are like, yep, good. Nope, I can't tell that they're the same. 4 minus 2 equals 2. Still can't tell they're the same. 2 equals 2. Now I can. That one's good. Then I check. N minus root n equals 2. 1 minus root 1 equals 2. 1 minus 1 equals 2. 0 equals 2. Nope. So what do? I circle it. I put a line through it. And I say extraneous. Because I could ask you for what is the extraneous root. And you would have to pick n equals 1 as your multiple choice answer. I could ask for the extraneous one. Then we have the last one. The last one is square root 3x squared plus 2 equals 2x minus 2x plus 1. I won't worry about the restrictions as much on this one. I'm just going to worry about can you solve it. So what's my first rule? Radical on one side, everything else on the other, correct? So do we have to do any steps to get that to happen? No, it's already there. Then once I do that, I square both sides. When I square a square root, what happens? It cancels. When I square a binomial, what should I do? Cross off the 2 and rewrite it. Bless you. Cross off the 2 and rewrite it. So I'm going to get 3x squared plus 2, and then I have to FOIL. 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. 1 times 1 is 1. So I get 3x squared plus 2 equals 4x squared plus 4x plus 1. I have a squared. Not only do I have a squared, I have 2 squareds. So what do I have to do ultimately? Get everything to one side and set equal to 0. The one that I think will be nicer is if I subtract 3x squared onto the 4x squared, I'll just have an x squared, which is much nicer than doing the other way. But you could move 3 terms to 2 of them. You can move the 2 to the 3 of them. I'm going to move the left to the right. So I'm going to subtract the 3x squared, and I'm going to subtract the 2. I could have moved the 4x squared, the 4x, and the 1 over as well. I could pick either way, but it has to be equal to 0. So now I'm going to get 0 equals x squared, or 1x squared, plus 4x minus 1. Can I factor it? Is there anything that multiplies to give you 1 and adds to give you... No. So what are you going to have to do? Quadratic formula. This is my A. This is my B. This is my C. So x equals negative b, negative 4, plus or minus the square root of 4 squared. B squared minus 4 times A times C, all over 2 times A. X equals negative 4, plus or minus, put it under your calculator, so you go 16 plus 4, which is 20. Then I'm done. Am I done? Am I done? Can I reduce my root 20? Yeah, what can I reduce it to? 4 and 5, right? So if I go over here, I go root 20. I can break it down into 4 times 5. The 4 comes out and it's a 2. So it's 2 root 5. So I can get x equals negative 4 plus or minus 2 root 5 over 2. Now am I done? No? I can take something out of the triangle. The 3 numbers, what can I take out? At 2. This becomes negative 2. This becomes 1. This becomes 1. If the 1's in the denominator, I don't need to write it. So negative 2 plus or minus root 5 is my answer. I can turn them into decimals and check them. They're both going to work. Your homework for this. Page 300, numbers 4, 6, and 7.